Hello learners, welcome back. As promised, I am here again with a video about coordinate system. This is a very important topic of electromagnetic theory. Three-dimensional coordinate system you might have studied in your previous courses in mathematics, but it was only rectangular three-dimensional coordinate system. In this video, we are going to see rectangular coordinate system as well. But along with that, we will see two more coordinate systems, that is cylindrical and spherical coordinate system. Because I cannot stress it enough that this topic is very important and it is interesting as well, and I'll try to make it as simple as possible, but I'll need your attention and your imagination. So let us start with the explanation. The coordinate systems are of two types. The three-dimensional coordinate system, obviously we are talking about. Two-dimensional coordinate system will not help us in electromagnetic theory. Each and every real world things are three-dimensional. Even a thin piece of paper is also three-dimensional because it has a little bit of thickness. So there are two types of coordinate system as we use in three-dimensional geometry in different fields. One is orthogonal coordinate system and another is skewed coordinate system. In orthogonal coordinate system, we have all the three axes, or we can say all the three surfaces that are involved in making a coordinate system, all are perpendicular to each other. So in this way they are known as orthogonal coordinate system. The three coordinate systems that are only three coordinate systems that we are going to study in electromagnetic theory, all three of them are orthogonal coordinate systems. In traditional physics or in any traditional subjects, we don't normally encounter skewed coordinate system because they are special coordinate systems. They tend to make only some specialized problem easy. In normal problems, if you try to apply skewed coordinate systems, they will make things complex. Why? Because all the three axes that are involved in making skewed coordinate systems are not perpendicular to each other. So the geometry involved in explanation of these coordinate systems will also become difficult. In orthogonal coordinate system, on the other hand, everything means all the axes are perpendicular to each other, and the geometry or the trigonometry which is involved in explanation of the directions and the dimensions in these three coordinate system is quite simple, means it's understandable. It's not that difficult. So let us start with the first coordinate system. You might know it already, but I'll try to make it easy and it will help to recall whatever you already know. So first is rectangular coordinate system. So let's see. In a rectangular coordinate system, if you want to locate a point, let's say this, for example, this point P here. So this point P has coordinates x, y, z. It means that this point, to reach this point, we have traveled a distance x in the x-axis. Then we traveled a distance y parallel to the y-axis, and then we went a little bit above towards the z-axis to reach this point. So that is how we are going to locate each and every point which is there in a rectangular coordinate system. Also, why it is called rectangular coordinate system? Because all the coordinate systems are named and they are classified depending upon the basic traditional shape that can be made using all the dimensions which are present in the coordinate system. For example, if this is axis x, this is axis y, and this is z, if I try to use all the dimensions in all the planes, one dimension that I'll get will be on the xy plane, one dimension will be on the xz plane, and the other dimension, a square or a cube, a square or a rectangle, will be on the yz plane. And if I try to make the parallel planes which are parallel to all these planes that I have made, I will get 6 planes that will intersect each other. So that's how you will either get a cuboid or you will get a cube. So the shape that we will get by joining all these planes, or we can say joining all the edges that are possible, we'll get a shape which is known as cuboid or cube. That is why this type of rectangular coordinate system is known as rectangular coordinate system or Cartesian coordinate system. So let us understand that what we can do and what is the analogies that we can use to understand a rectangular coordinate system. Let us consider a room, and a room is normally of a cuboid or a cube shape if all the walls are of same size, but let's say this is a cuboid and we pretend that this is a room. So every room has some height, has some length and breadth. So this room also has all these three dimensions. Let's say there is a small fly which is there inside the room, and this fly moves anywhere in this room. But to locate this fly, we have only one possible method. We have three axes here. One is z-axis, one is x-axis, and one is y-axis. And with the help of these three axes, we have three planes. As I have already told you, we have xy plane, we have xz plane, and there is another known as yz plane. So we can either use three axes or we can use three planes to locate the position of this fly at any point of time. The way is simple. The way is like this p, x, y, z that we are seeing on the left side. See, any point of time, for example, this fly moves 3 meters towards the x-axis, 4 meters towards the y-axis, and 5 meters towards the z-axis. So we have three different dimensions, and we can follow one dimension at a time and reach the location of this fly. That is how rectangular coordinate works. Now let's see that what all distances we can travel using these three dimensions. We have three dimensions. One is x length, one is y length, and one is z length. So ideally, we don't have any restrictions on these three dimensions. X-axis is starting from 0 right now, and we are only considering it towards the positive direction. In this diagram also we are saying that it is moving in positive direction. Here also we are saying that it is in positive direction, but we are doing this only because to simplify things. But this x-axis can also move towards negative direction as well. So this x-axis can go backwards, this y-axis can also go backwards, and this z-axis can also go downwards towards the negative side. So if we say what are the possible places that this x, y, and z can go, so the answer is it can go anywhere from minus infinity to plus infinity, all three of them, right? So these are the limits to which your x and y and z can extend. This we should always remember, because it will help us in the problems where we need to integrate something with the limits. So x can have any limit between minus infinity to plus infinity.